Hi everyone, and welcome to our video on the even-odd properties of trigonometric functions. So cosine is an even function and sine is an odd function. And what that means is that cosine of negative t is the same thing as cosine of t. So let's box that. So it's saying you can kind of just remove the negative from cosine if you want to. So these are properties that you can use if you want to. You don't have to. Okay, so and then the sine, let's just box the main two. Sine is an odd function, which means that if there's a negative value with the t, it's kind of like taking it out. You can take it to the front and then make your t positive. So for instance, on this number one, and then the other four, remember they're just connected with sines and cosines. So if we know sine and cosine, we can get those other four anyway. So it's just making those fractions. Okay, so let's use the even and odd properties on these functions. We'll actually show it two different ways. Let's use the even and odd properties first. Okay, so what this is saying, because this is a negative right there, here's our even property. Even property is saying we could do this exactly just like cosine of positive 11 pi 6. So these two would be the same value. Okay, and let's show that on the unit circle. Let's show them both and show why this property works. Okay, so the positive 11 pi 6. Okay, so 6 is in a denominator. So I know it's one of the ones that are close to the x-axis. Again, I'm trying to draw it accurately to show like short versus long. So I know it's one of those four. And then 11 over 6 is close to 2. So remember, here's where it starts and then it goes all the way around to 2 pi. So 11 over 6 is close to 2. So that means it's this one. Okay, so let's show that one in red. So that is going around right to there. Okay, and with 6 in the denominator, we know our terminal point is the square root of 3 over 2 and 1/2, but make sure you're in the correct quadrant with the sign. So if we're in quadrant 4, that means the y-coordinate should be negative. Okay, so that is our terminal point for the 11 pi over 6. Okay, so that means our cosine is this x value, the radical 3 over 2. So that is the answer to this question. Now let's go back and show the negative 11 pi over 6. Okay, so that's using the even property. Again, you don't even have to do the even property to evaluate this here. If you want to keep it negative, you could keep it negative. Okay, but the 11 pi over 6, the negative 11 pi over 6, remember that's just saying go clockwise. Okay, so it's going to get a little messy here, but it's going clockwise, but it would go the same length as that red length. Again, just clockwise, which means it would end up right here. Okay, so that would be where that terminal point is. Well, that terminal point is in the first quadrant. In the first quadrant, with 6 in the denominator, it would be radical 3 over 2 and 1/2, both positive. While the cosine is based on the x-coordinate, this x-coordinate is the same as the other x-coordinate, the radical 3 over 2. Okay, because they're both to the right of the y-axis. Okay, so they're the same length to the right, so that means they're the same x-coordinate. Okay, so that's why we can use this property. Okay, so that's using the even property with cosine. Let's do the odd property with sine. Okay, so if we're doing the odd property, again, we don't even have to, but just to show it first, the odd property is saying you can do negative sine of 2 pi thirds. Okay, so this one, we got to be a little bit more careful with. So cosine's a little nicer. I'm going to put that in a bracket. So what this is saying is do the sine of 2 pi thirds and then make sure your negative is still there. Okay, so it doesn't mean your answer is just automatically negative. It's saying do the sine of 2 pi thirds, get that answer, and then afterwards see what happens with the other negative. Okay, so let's do this same thing. Let's sketch it out and show both. Okay, so we have sine of 2 pi thirds. So I'm focused on the positive angle. Let's do that in red again. Okay, so if 3's in the denominator, I know it's got to be close to the y-axis. So it's one of these 4 terminal points. 2/3 pi would put us in the second quadrant because 2/3 is less than pi. So here's where pi is. So 0, 2 pi. pi's to the left. Okay, so we know it doesn't go all the way to pi, so it's somewhere in quadrant 2. So this red one, so this is that 2 pi thirds length right there. And then with 3 in the denominator, we know our point involves 1/2 and radical 3 over 2. And then, but make sure quadrant 2 means that x should be negative. Okay, so we have negative 1/2 and radical 3 over 2. So if I wanted to continue doing, let's finish this odd property problem up right here. Remember, the sign is to use your y coordinate. So it's saying sine of 2 pi thirds is the radical 3 over 2. And then now we'll deal with that negative. So on this problem, the negative and a positive would give us a negative value. So negative radical 3 over 2 is that answer. Okay, so that's using the odd property. Now let's go ahead and do it without the property. Okay, so here's our, I'm going to put it in blue, just the original sine of negative 2 pi thirds. The negative 2 pi thirds, so the negative is telling you go clockwise. It's that same length in the red, just going clockwise instead. Okay, so I drew the same length going clockwise, and that puts us in quadrant 3. Okay, so quadrant 3, let's keep it in blue, has the terminal point negative 1/2 and negative radical 3 over 2. So sine of negative 2 pi thirds is saying take that y coordinate as it is, and then that is the final answer. So negative radical 3 over 2. That's it. Okay, so notice again, it's the same thing. So it's a way to also check if you do have a negative angle and you want to, or a negative t value, so those are also angles. It's a way to check. So there's more than one way to find these answers a lot of the times. And we're just trying to add to the library of methods that you can use. Okay, one other problem here with even and odd. Sometimes they like to just mess with these functions, and here they give secant and cosecant. All right, so what we would do instead, so I only box those two with cosine and sine. So they give us functions, but remember that secant of x is the reciprocal of cosine, so 1 over cosine of x, and then cosecant of x, so this is times, is the reciprocal of sine of x. And if they're asking if something is even, odd, or neither, for it to be even, they just want to, so even, let me make that a question mark instead. So if they want to see if something's even, they just want to see, well, what happens if you plug in negative x? If we plug negative x into these, just like that, so we're changing the x into negative x, we get this expression. And then now I'm going to use my boxed information up here and apply their properties. So it's saying, well, the one with the cosine of negative x, that is just cosine of x. So that's using that property right away, and you can keep that in parentheses too. And then times the 1 over sine of negative x, well, this negative here, again, using that property is saying you can take it to the front. Okay, so we're going to take it all the way to the front, and then I'm going to rewrite my sine of x. Okay, so I could have wrote it right in the front of sine, but then negative multiplies anyway, and you can move things around. So that's what I wanted to do. I just wanted to move it right away to the very front. Okay, and the even gives us this expression. Even is true if f of x equals f of negative x. And so comparing our two answers, let's highlight. So f of x is this statement. F of negative x is this statement. And so they're not the same. One is positive, one has a negative in front. So that means it's not even. Okay, so it's not even. Now we need to see if it's odd. Odd is when this is true. Okay, and this kind of is a review of some algebra stuff. This is kind of minor in the long run of trig functions. The main thing is these two problems above. Okay, so being able to evaluate. Here's something that they might ask about, so I just wanted to make sure we did cover it, but it is something that's probably not super important. Okay, so but let's make sure we can still work with these functions. Okay, so it's odd if this is true, if f of negative x equals negative f of x. Okay, so I already have this. Let's keep it color coded. So it's that same pink statement. Negative f of x. Let's go and put that in red. So I don't want to do any other new highlighter. That negative is just saying put a negative in front of your whole f of x. So negative, our f of x is what's highlighted in yellow, which is 1 over cosine of x times 1 over sine of x. And I put the brackets there in case we needed to distribute, but because it's all multiplication, then there's no addition or subtraction. I don't need those brackets. So it really is the same as this expression, which is the same as that pink highlighted from before. So these are the same. Okay, so it is odd. So on this problem, it is odd. Okay, so odd. Okay, which is kind of helpful for graphing. Okay, so that's one reason we like to talk about even and odd with the functions. Okay, however, you kind of probably don't need it at all. Okay, so this is just to try to help really again with these problems. I'm gonna put a little star on that. It's this is the main thing. Okay, anyway, but it's been covered now in case you have to worry about it, but like maybe 1 or 2 problems on the homework. Okay, other than that, I hope everything else is going well. If you have questions, please let me know, and thanks for watching.